Okay, ladies and gentlemen, we're on to our next problem for today. This is AP 2017, number 1. It says number 1. And it is a calculator question, and we're going to start bringing in the calculator to look at problems. I see a set of data. I'm either going to be estimating area or estimating slope, something along the problem here. A tank has a height of 10 feet. The area of the horizontal cross-section of the tank at height h feet is given by a function a, where a of h is measured in square feet. So I'm going to mark these off here. This is height. This is cross-section area. Okay, area is in feet squared. The function a is continuous and decreases as h increases. Okay, so the area gets the area of the top of the tank gets smaller as time goes by. Select values for a of h are given in the table above. Use a left Riemann sum with 3 subintervals indicated by the data in the table to approximate the volume of the tank. Indicate units of measure. So your left Riemann sum, we started on the left side. It'll be 1 rectangle, use that height. 2 rectangles, use that height. 3 rectangles, use that height. When you do a left Riemann sum, you leave off the last value. When you do a right Riemann sum, you leave off the right value. So, and this is a calculator question, so I'm going to write this out. I'm going to call L3, doing 3 Riemanns, is equal to the width of the first rectangle, which is 2, and a height of, I should have mentioned this when I started, that I should draw a picture at first, and you'll see the first rectangle is here, second rectangle is that height, third rectangle is that height, and the last one doesn't make one. And the widths of each one are 2, 3, and 5. So L3 is going to be 2 times 50.3 plus 3 times 14.4 plus 5, 6.5. We would write that all out, but they want this on a calculator, so I'm going to bring a calculator over here. I've turned on the contrast just to help me out. I'm going to start a new document. I'm not going to save my work. Hit a calculator page. And using the parentheses, I'm going to add it in. 2 parentheses, 50.3 plus 3 parentheses, 14.4 plus 5 parentheses, 6.5, close parentheses, enter. So the answer is 176.300. You're always going to write it to the thousandths when you can. And I'm asked to indicate units of measure. Well, if area is square feet, then L3 is going to be volume, and that is going to be in feet cubed. Remember, dimensions always go up from distance to area to volume. This is first degree, second degree, and third degree. Okay, so that's part A, usually the easiest part on there. Now let's take a look at part B. The question says, does my statement under or overestimate my left Riemann sum? And the way I would visualize that is by having my sketch, which I had before, and left Riemann sums start on the left side of the curve, so I'm just going to draw them. And you can see they overestimate. So B, the answer for B is it overestimates. Now it asks to explain your reason. A couple things you can write down. You can write down C picture, left Riemann overestimates, and just describe your curve. A decreasing, concave down graph. Now, the answer is all that information might not matter, but what I've done is I've just written down what I know about the graph. It's obviously decreasing, and it's obviously concave. Gotcha. Psych. Thought you were getting $1. Not getting $1. Concave up graph. The other parts are usually pretty straightforward. They want you to either integrate or derivate using your calculator and give us complex functions. The area in square feet of the function is given by this new function, f of h. They want me to find the volume. Now, if I integrate area, I get volume. So I'm going to find the integral of 50.3 from e to the point 2h plus h dh. So the question is, h is my variable. What height am I starting at, and what height am I ending at? Well, let's take a look and see if they gave that to me in here. Tank is a height of 10 feet. So I'm going to start integrating at the bottom, finish integrating at the top, and I'm going to do that right in the calculator. No sense even trying to work it out. So menu, calculus, integral from 0 to 10 of fraction 50.3 over e e to the point 2 h over plus h dh. I'm just going to read it again to make sure I got it right. I've got 50.3 over 0.2 h, 0.2 to the e to the 0.2h. There we go, put that right there. It's HDH. Hit enter on my calculator, and I'm going to get an answer of 101.325. You need to round to the nearest thousandths place. Always write down the integral you used and the number that you have right there. It also asks me for units of measure. I'm just going to check f is based on square feet, so this is going to be in feet cubed. Always going to be a challenge. They don't want to make that part easy on you. So let's take a look at what's going on here. Water is pumped into the tank. When, I've got a when thing, I'll write this down. When the height of the water is 5 feet, the height is increasing at a rate of 0.26 feet per minute. So dh dt, when h equals 5, equals 0.26. Using the model from part C, find the rate at which the volume of water is changing with respect to time when the height of the water is at 5 feet and indicate units of measure. So they give me an equation, F equals 50.3 over. Okay, so I'm going to put the information on our problem right here. And let's take a look. We are doing, I'm going to pause this. Okay, so once again, we're looking at our functions. F is the area based on height. Okay, and dh dt is what they gave us. They want us to find df dt when h is equal to 5. Okay, so since we know that the volume at any given height from 0 to h is equal to f of h dh, we then know what its derivative is going to be. We know that dv dt equals, so the derivative of this statement right here is the derivative of this. Now it's an h, so to drop the top, f of h fills in the same spot, times the derivative of h based on time, which is dh dt, which is equal to f of 5 times 0.26. So I'm going to pull up my calculator, and I'll find f at 5 by going... Oh, Ella's just walked in as we're recording the problem, which is 5. She's laughing. I'm going to pause it for a second. Okay, so here's the last part. That's the last part of the recording. So what I did is I had to find f of 5. I put 5 in for h, and I got 6.571. I can write that down. 6.5710. Then I multiply that by 0.26, and I got 1.6944, but we're rounding to the thousandth spot. 1.694. And they ask for units of measure. Well, if f is measured in feet squared, then the rate of change of that is measured in feet squared per whatever our time unit is per minute. Okay, good job. See you next class.